As we continue on Chapter 1, we're doing today 1.4, which will deal with exponential notation and then later scientific notation. Here we're featuring the product and the quotient rule, which is if we are multiplying variables with the same base, we just add the exponents. And the quotient rule, quotient refers to fractions. We take the smaller one actually, or in this case it's the m, bring it across the division bar. When we do so, its sign changes and we just subtract. Items 1 through 5 are matching, so give it your best shot. Of course, this is after you do the lesson that we have in class, and see how you do on it. And then you can check your answers at the end of the chapter. So as we go to number 6, here we're using the product rule. We are multiplying 5 times 2, that'll be 10. And then n to the 8th, n to the 3rd, add the exponents, n to the 11th. Here's another example. One of the factors is negative. So that technique we spoke of in the previous section, determine what your end sign will be. It's going to be negative, so put that there. Then 4 times 6, that's 24. A to the 2nd, a to the 5th, add the exponents, a to the 7th. B to the 7th, b to the 4th, b to the 11th. And here they're slipping in something that any variable or number that's to the 0 power, that's equal to 1. So we just don't write it. There's a 1 there. Now we're doing the quotient rule, where we're going to subtract our denominator's exponent, or as it crosses that division bar, the sign of the exponent changes and becomes something like that. So this just becomes t to the 6th. And also referring to something we did when we divide unlike signs, the sign of our final answer is going to be negative. Then 8 goes into 40 5 times. X, there's a 1 there. Subtract it from 5 gives me x to the 4th. Y to the 8th subtracted from y to the 10th gives me y to the 2nd. And this is going to become z to the 0 power, or just 1. Anything divided by itself is 1, and we don't write it. Okay, going on. Here they're asking us to do some replacement, some substitution, with x being a negative 3. So I'm going to take that x out and put in there a negative 3. Okay? Now, let's do it. So, anything we said to the 0 power is 1. So what we have here is 1. 1 times negative 5 is negative 5. Now, since this whole thing is in the parenthesis, and that's to the 0 power, anything to the 0 power is 1. This is 1. Now, even though we changed that, that would have been a positive 15, but positive 15 to the 0 power is 1. Anything to the 0 power is 1. Now, for these next few, they want us to simplify. Keep in mind this is negative 7 times negative 7. That's going to be a positive 49. This one's a little tricky because this is 7 times 7. Then we apply the negative. Now, this is an area where many students get it wrong. If you're not careful, here, because of the parenthesis, it's negative 7 times negative 7, a positive 49. Here it's a 7 times 7. The only thing that's raised to the second power is the 7, not the negative. So you can think of it this way. That's the way that is, although they write it like this. Negative 49. Now, this one, because of the negative exponent, we need to take it. This is really tricky because, in a sense, this should be written like a negative 1 times 7 to the negative 2. So the negative 1 stays up there. The only part that comes down is the 7 when we change the negative exponent to a positive exponent. So number 14 becomes a negative 1 over 49. And that's how it happened. So you don't need to do this step in a sense. Just keep in mind that the only thing that comes down is the 7. The negative 1 stays on top. And then that becomes a positive when it crosses that division line. Now in this case, keep in mind there's a 1 out there. So this is going to be a 1 over, in parentheses, negative 7 squared. This now, as it comes down across the division line, the sign of the exponent changes. So this one is going to become 1 over 49. So a lot of little subtle differences here. And again, if you need to back up the tape, you can and watch it again. But a lot of interesting stuff going on here. Okay, for all of these, they want us to write with positive exponents and to simplify. So this is going to become, keep in mind there's a 1 there, so that's 1 over 6 squared. We bring the 6 to the negative 2 down to the denominator, and it becomes a positive 2. So 6 squared is 36, so 1 over 36. This, since it's negative, we're going to bring it up, and this becomes 2 to the 5th. This goes up, crosses the division bar, the sign changes, and 2 to the 5th is 32. I happen to know that one. All right, in this case over here, the 4 stays up. The a to the negative 5 goes to the denominator. And now everything is in positive exponents. In this case, we have x to the 8th is good. The 2 stays there. But now the y to the negative 3 comes down to the denominator. Put that properly here. And the z to the negative 10 goes up. So again, that rule of crossing the division bar, we change the sign of the exponent to make it positive, or whatever the sign is. In this one and this one, they want us to write the variable with negative exponents. So we're switching things around. So that's going to be 2. So c to the second comes up as c to the negative 2. And the 3 stays up, and we bring x to the negative 8. Now here is to simplify, and only with positive exponents. So it's 6 and 1 are 7 minus 2, x to the 5th. 3 times 7 is 21. C to the 5 plus 15, that'll be c to the 20. And this is going to be d to the negative 4. A negative 6 and a 2 gives me a negative 4 that I bring down to the denominator, and I get a positive 4 down there. And then here I'm just bringing the negative 10 up. It's going to add it to 6, so this becomes t to the 16th. Get a lot of stuff going on, but again, useful in practice. Okay, I just added raised to a power rule. That is, if we have a variable with an exponent that's raised to a power, here we multiply the exponent. So we'll see some of that as we go on. So in number 25, and again it looks complicated, but take it step by step. First, what will the final sign of the answer be here? So positive divided by a negative. So it's going to be a negative. And it's sort of like a 1 over 4. 3, 12, 1/4. Now, x to the negative 5, bring that negative up to the top, it's going to become positive. That's going to be x to the 10th. Now, here we see that this exponent is smaller than this, so we're going to bring it down to keep it positive. This becomes a negative 2, positive 3, so in the denominator that's just a y. Y to the first, we don't write the 1. And here this z to the negative 8, it's going to cross that bar, become a positive 8, so that gives me z to the 3rd. And we don't usually write the 1 there. So our answer is a negative 10x squared z to the 3rd all over 4y. And that's correct. Yep. Now here we're raising to a power, and there's a 1 by the 3, so 3 to the 2nd power, I'll write it like that for now, r 4 times 2, r to the 8th, s to the 6th, and then 3 squared, that's going to be 9. So we'll make that 9. But I wanted you to see where it came from. All right, this one, a little more complicated, but let's just do it. This is going to be 5 to the 2nd power. That's going to be 25. Y to the negative 3 times 2, y to the negative 6. And then it's times 4, y to the 5th. Then in the bottom, we're going to get 2 cubed, or the 3rd power of 2, which is 8, y to the 12th. So we did some simplification. Now, notice what I could do here. There's a 4 there, and there's an 8 there. I can actually do some cross-canceling. That's 1. And this is going to become a 4 goes into 8 twice. So I can change that to a 2. And that's just the 1. Okay, now my y is to the -6. I'm going to bring that down. I'll write it over here. So this is going to be 25 over 2. Y to the -6 comes down, adds to the 12, and that makes that y to the 18th. And I probably should have done this other y first. Okay, so this is going to be y to the 5th. I hadn't done that, so I have to subtract now 5 from that, and that's going to make that a 13. So that should be my answer. And that is correct. Again, when they're complicated, you're going to have to say, how much do I have to put in there so I get the right answer? Again, you might have put 2 to the 5th instead of 25. But again, put enough work so you're sure to get the correct answer. As we look at these next two, they are pretty sophisticated, and let's just take it step by step. So here we have 3, remember there's a 1 there, to the 4th power. So this is going to be 3 to the 4th. A, -2 times 4, -8. B, -20. And this is multiplication, so this is going to be 3 to the -5. Remember there's a 1 there. This becomes A to the -20. And this becomes B to the 15th, positive 15. -3 times -5, 15. So right now it looks a lot easier. So what do we have here? Well, we got the same bases. This is a +4, this is a -5. So this is going to be 3 to the -1. Now we have A to the -8, A to the -20. That becomes A to the -28. This becomes B, -20 and a +15, a -5. Okay, so let me put it over here then. So remember there's going to be a 1 on top because everything else is going to go down. They're all negative. So this goes down as a 3 to the 1st. We don't write the 1. This becomes A to the 28th and B to the 5th. Now it's important that you have that 1 up there in the numerator occupying that spot. Okay, let's do this one. So there's a 1 there. This is going to become 2 to the -3, A to the -15, B to the +3. So -5 times -3, -15. -1 times -3, a +3. Now this becomes 3 to the -3, A. -4 times -3 is a +12. And this becomes B to the -3. Okay, once we do that, maybe a little easier to do. So let's do some conversion. We know these two are going to switch places. So this is going to be 3 to the 3rd in the numerator, this is going to be 2 to the third in the denominator. Okay, this one's positive, this one's negative. We want our answers to be negative. So we're going to take the a to the negative 15, bring it down, and that becomes a to the 27th. So a positive, when it comes down, 15 plus 12 is 27. And this, as it goes up, becomes a positive b to the 6th. This is a negative 3 here, crosses the division bar, it's going to change its sign, add it, gives you that. Now, we just need to simplify this. 3 to the third is 27. 2 to the third is 8. And then that will be b to the 6th, a to the 27th. Again, rather tedious, but just take it slow and watch it step by step. Some of these steps you may have put here, well, here you had to get the right ones. I might be able to flip that in my mind, but chances are doing it, you need to do it accurately. So I strongly suggest this method here. Okay, as you see here, we're going to scientific notation. And by definition, scientific notation is a number that's greater than or equal to 1, but less than 10. So we have to put a number between 1 and 10. And then when we convert it, well, in fact, let's do these first. Then we'll get to those. So our decimal point is here, and we count the number of places to put this number between 1 and 10. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We had to move that decimal place to the left 10 places to get this big number to be a number between 1 and 10. And then we use the multiplication sign, not an X, but the multiplication sign, and then it's going to be some power of 10. And since we moved it 10 to the left, it's going to be a positive 10. So that's this number in scientific notation. Now, the same thing here, but this is a very small number. So we're moving the decimal to the right. 1, 2, 3, 4, 5, 6. So 9.56 times 10. And since we moved it to the right now, that's going to be a negative 6. So that's the scientific notation for a small number. The exponent on the 10 will always be negative. So here, this is a negative exponent. So there's our number. Now our decimal was here. So how many decimal places do we need to move it? And it's to the left now, and it's going to be 6 places. Well, there's 1. So we need to add 5 zeros. 1, 2, 3, 4, 5. Our decimal goes there, and we usually put another 0 to fix the decimal place. So this is a positive exponent. We have to move that place, that decimal place, 7 places. Well, when we write this number out, there's 3 already. So 8, 0, 3, 4. There's 3 places, and we have to add 4 more zeros. And there's our answer. And we can put commas in there if we like. Okay, again, you're going to practice and work on your skills.